All right. I hope you enjoyed that video. And Ben, thanks so much for the introduction. And it's really our pleasure today to represent and present this sort of big team effort in response to the COVID-19 pandemic. So as painful as it might be, let's take a step back to March 2020, which was only a few months ago, but might feel like several years to many of us. And just to remember that on March 11th was the day that the university closed in response to the pandemic. And sort of just remember what that was like, where flattening the curve was sort of our key, one of the new vocabulary that we were learning. And about that time, news stories were popping up about the extreme shortage of personal protective equipment, or PPE, that our hospitals and our health professionals were facing at the time. When those, at the same time that these press releases were coming out, my friends from graduate school and who were now working at hospitals in DC and New Orleans and New York were reaching out to me, explaining their concerns and frustration. And I can tell you that it was really terrifying to hear a doctor express fear. That's not really a profession that we're used to, right? It's always someone standing by our bedside saying everything's going to be okay. And when you get that kind of phone call, it's really harrowing. Now, on March 16th, we started seeing these stories coming from Italy about the use of 3D printing technology as a means of sort of as addressing this gap in supply. So this global supply chain had broken down due to everything shutting down. And these Italian researchers have found a way to actually produce spare components for ventilators, right? Because that was one of the major concerns, was the lack of ventilators. And when these press releases came out, my students and I took notice, and we started coming together to think about how we could use our lab, which is focused on additive manufacturing, to help in this pandemic. Similarly, my friends, these doctors, were reaching out to me and saying, hey, can you use 3D printing? Is there anything you can do to help? That's how desperate the situation was. So what we want to do today is sort of talk to you about how we sort of coordinated as a university our response to make sure that our resources and expertise were put forth in the best and most efficient manner possible. So before we begin to tell you some of the sort of vignettes of all the different projects we worked on, we want to acknowledge all the folks who jumped on. And it's really hard to even present any names here because we can't fit all the names of the people who helped onto a single slide. So I just put some here. We had over 75 faculty, staff, and students come together as one unit to address the potential for PPE shortage in our New River Valley region. And more important than the names, perhaps, is the interdisciplinarity of this effort, which of course featured lots of engineering, different departments that were sort of using their manufacturing equipment, their making equipment, and their knowledge about manufacturing and materials. But also we had faculty from the College of Science, like Mark Michel, a geoscientist who all of a sudden, was using 3D printing to support his research, really to make, objects that, as fixtures or other tools, now turning those, tools into making PPE. Of course, we had our friends from industrial design join us. And of course, our sort of health side of our Blacksburg campus, as well as the health side of our new campus up in Roanoke. And really, that was a core piece where we actually were, essentially receiving customers of our doctors, both who are, faculty here on our campus at Virginia Tech, but also their colleagues working alongside of them. And of course, we have to acknowledge all the support that we receive from the investment institutes, especially ICAT, where Ben really graciously provided some additional support for Joseph over the summer so that we could continue to keep the Create Studio open to use the tools there to make the PPE as needed. And of course, we had Max Offset from the library and all the equipment that he brought. He actually brought his equipment home and started working on the projects there. We even engaged local companies and their expertise. And we even had 2 high school students involved as well. So again, over 75 total folks from all over our community. And we came together, instead of each doing our own individual projects, we came together to sort of standardize the products that we were making to make the adoption that much easier for the hospitals, and also to ensure the integrity and safety of the things that we were making. And again, really just to sort of maximize our efficiency at this critical time. So over 13 projects were identified, and this came in collaboration with our the faculty and staff at Carillion of what they felt was needed. And some of them are PPE items like N95 replacements or nasal swabs, but they were also sometimes inventions that the doctors themselves had come up, like that picture in the top right there of a sleep apnea machine being converted over to a ventilator. So today, unfortunately, we don't have a lot of time. We'd love to tell you all the stories and all the people involved, but we're just going to focus on 3 quick little stories and be happy to answer any questions afterwards. So we're going to start with face shields. And as you could see on the previous slide, the way that this was coordinated was that we had faculty and students volunteer to lead several other faculty and students in the coordination of each individual project. So Alex Leonessa, professor of mechanical engineering, and Liam Chapin, an undergraduate student who also works in a research lab in the Department of Mechanical Engineering, came together and volunteered to lead this effort of crowdsourcing the production of face shields. So let Anand tell you a quick version of the story here.
My name is Anand. I'm a postdoc working here at Beam. And about a month ago, when we started to see all the news reports out of New York, they were concerned about PPE shortages and there were stockpile shortages across the United States. Then you started to see how in the Czech Republic and in Italy and Spain and other places, engineers were coming together to convert scuba masks into ventilators, or they were 3D printing PPEs. That got me thinking, we have 3D printers here in lab, and we've got a bunch of other 3D printers in almost every lab has one or two of them.
Sorry about that.
See how in the Czech Republic, coming together to convert scuba masks into ventilators, or they were 3D printing PPEs. That got me thinking, we have 3D printers here in lab, and we've got a bunch of other 3D printers in almost every lab has one or two of them. Why don't we start making PPE with that? So I gathered a couple of them. I contacted a couple more faculty members, and we sort of consolidated the 3D printers. We were trying to figure out where to get started. There were a bunch of designs online which had already been used in the Czech Republic, in Italy. And so we started printing those out. And then a lot of people on Tech's campus had the same idea. So the main effort push for sort of consolidating this into one effort came from ME, which was a great help. Christopher Wills was one of them, Dr. Alexander Leonessa, who brought this whole sort of effort together. There were a bunch of doctors, they were reviewing whether the PPE could be used or not, and then there was a sort of back and forth where a couple of samples were printed out. The doctors and nurses tested them, came back with feedback on this is not covering enough, or this is a little too uncomfortable for us. So then we, in some ways, we did over-engineer the designs which you had seen being used online. That's what we do as engineers.
So Anand, had done some coordination within his department. Faculty were volunteering and providing him, moving their 3D printers from their lab to his. But then we sort of found out, and we all came together to sort of finalize a standard design. And I want to share a quick story of that design process where Dr. Keel, we're all using Slack. We had 75 people on Slack. Dr. Keel came on from Carillion Roanoke and started providing input on the design and making sure that our design could pass their inspection, which had some pretty high standards. And at 11:13 at April 9th, Dr. Keel comes on to tell us that our current design isn't going to pass inspection. And within just a few moments, Liam Chapin comes in with a new idea about how to, basically the big design criteria was, will it provide coverage over the forehead? By 11:30 that same day, Liam's got an idea of a prototype using paper. Dr. Keel comes in with some additional feedback. Genevieve Gural, a PhD, a master's student in mechanical engineering, comes in with an inspiration from IKEA, of course, and she's got a new idea. Liam starts continuing to prototype his idea, and by noon, about 1 p.m., Genevieve is prototyping ideas on paper. All is happening in real time, all virtually. And by 2:30, Genevieve has the first prototype of the new idea, which basically is to provide coverage over the forehead, but without having to increase printing time dramatically. And by 5:30 that day, so it started at 11:30, the customer saying this isn't going to work, but by 5:30, they've got a workable solution that has reduced costs and is a more efficient production. And Dr. Keel says, this is incredible, this is outstanding, let's do it. And so it's that kind of exciting, lots of virtual collaboration and using the tools available to push this forward. So from that, we could crowdsource the production, we put the design online, and everyone in the town, the local students and all the community use their 3D printers. The first day of collection was 200 face shields, and that quickly over the span of 2 months led to 6,000 face shields being distributed in the New River Valley region. Those face shields were then disinfected and then sent up to Roanoke, where they were assembled by the Carillion medical students and then distributed to all of our health clinics and folks around the region and even throughout the state of Virginia. Joseph, tell us a little bit about the 3D printed respirators.
Yeah, so as a bit of a different example in terms of how you need to be a little bit more careful with 3D printing. In this idea of 3D printed masks, there was a big shortage in N95 and surgical masks in the community as well. We saw a number of designs coming out of different research labs, different individuals trying to address that shortage themselves with a number of different designs for face masks. But the question that no one had really taken the time to answer was this idea of, can these masks, these 3D printed masks, actually be used as viable replacements for the N95 mask? And we were pretty well positioned at Virginia Tech to answer this question with the help of Lindsay Marr's group, where they actually were able to do the filtration efficiency testing in their lab space. Basically, they could hook up the mask to a device, push aerosolized particles through that mask, and actually evaluate the filtration efficiency of those masks. I think there's some, there we go, yeah. And so, yeah, basically addressing whether or not these masks were viable. So we printed 3 or 4 different models that were kind of widespread online over 2 different processes. And we also did some post-processing techniques to try to increase their filtration efficiency. But essentially, the printing defects, build orientation defects meant that the air wasn't being properly focused through the filter, and the filtration efficiency suffered heavily. As you can see in the bottom right, the top green dots are the traditional N95 mask, and the collection of data down below is all of the 3D printed masks. And you can see at best they were around 50% efficient in terms of filtration. So all that is to say that we wanted to make sure people were safe when they were printing off these masks. And we're not to say 3D printing can't be a viable replacement for masks, but you need to be very careful in terms of your calibration to your process, your printer, and you need to do this filtration testing to make sure you're actually providing a safe piece of PPE to the community.
Yeah, and that's an example of sort of not only the rapid engineering we did, but also the rapid science. And we did try our best to get that information out as quickly as possible so that people weren't using and had a false sense of security of, people donating and their best, they're trying to do their best to help, but they're donating maybe faulty products. So as a result, sort of in the background, we're also coming up with another idea of how to get there using 3D printing. And you saw that in the opening video. I wanted to give Genevieve a moment to talk about her efforts and the ideas behind that vacuum formed respirator.
My name is Genevieve Farrell. I'm a graduate student in the Dreams Lab, and we're working on essentially an N95 replacement respirator. The idea behind this product is we wanted something that was rapidly scalable, but something that we could also rapidly prototype and iterate components. The idea with vacuum forming is we start with this single impermeable sheet, and all we're doing is warming it up slightly so it gets a little more pliable, and then when we pull it over the form and pull vacuum, it's just shaping it. We're not poking any holes in it, we're not doing anything else, so we can be relatively confident that we don't have those leak paths that could let particles in. Our goal is to be prepared. So in the eventuality that there is a critical shortage of masks around it, and specifically respirators, we would be able to fill that need, and we would already have done all the development work required to make sure that not only are we producing masks and respirators that look like they should, but that actually perform well.
So here we're using 3D printing to rapidly make tooling. So we then take a more conventional process that actually also operates much faster. So we can make about 5 masks in just about a minute and a half through a vacuum forming process. So we made them in small, medium, and large, and we actually were fortunate that a local company in Floyd actually manufactures the N95 filter material that can be in a much smaller version, be inserted into the mask, and therefore the whole mask can be reused. So instead of just disposing of your N95, you can actually just simply wipe it with like a bleach solution, and it will be sterilized and ready for the next use. And with a local company, NanoSafe, we're able to validate that this mask actually performs equivalently to an existing N95. A lot of it thanks to that really nice, interesting 3D printed tool and mold that we made for a conformal fitting silicone gasket. Joseph's going to close us out here with one last story about how we made a reusable viral filter shell.
Yeah. So again, there's a shortage in these kind of disposable filter shells, and the nearby hospitals were looking for a sterilizable, reusable version of this component. And so one of my lab mates, Logan Sturm, did a lot of reverse engineering work on this part, and determined that we could actually design a part that would be autoclavable using our kind of high temperature materials we have available in the lab. And so his design was this kind of snap together piece. You can see him kind of executing that assembly in the bottom right. It was actually a lighter design than the original, and using that same filtration efficiency testing, it did seem to pass the original requirements. Also, all printed support free, and through careful design, he was able to minimize those printing defects to ensure that airflow was directed through the filter. And as you saw in the intro video, we did have to do some laser cutting to custom make these new filters for the component, in order to actually drive that efficiency up and get it to fit in the shell as desired. In the bottom left, you can see the filtration efficiency of our new 3D printed version. We've currently produced around 130 of these 3D printed pieces and around 1,200 of the filters, and production is ready to be scaled up if the need should ever arise.
And they're currently being used by a local EMS who ran out of supply, and they're used basically to place over the ambu bag so that they don't expose themselves to potential virus when they're resuscitating someone. So with that, we'll say thank you so much, and happy to take on any questions you might have.
Great, thank you so much for what a great presentation, and what a fabulous story of things happening at Virginia Tech and in the Blacksburg community. We do have some questions coming in. If anyone else has questions, feel free to put them into that, hit that link. This is a question for Joseph. David's asking, the 3D printed respirators topped out at 50% versus the N95. What does that translate to in terms of practical protection? Is that better or worse than like an off-the-shelf mask? Maybe even a cloth mask or some other, how does that work?
So we did actually.
Is it better than nothing?
It's better than nothing, but I in terms of actually giving it to medical professionals, it's subpar. Lindsay Mars Group actually did do testing on the cloth masks and t-shirts. I don't know if we have that data available, but basically even those pieces of kind of homemade custom equipment were better than the 3D printed masks. So you'd be better off wearing a cloth mask than the 3D printed respirator.
Mm-hmm. We have kind of a theme going. A couple of people have asked about kind of what we've learned from the process in terms of what insights and lessons can be, this is from Ashling, what insights or lessons can be used from this that would be useful for more centralized forms of disaster or shortage relief? So things like Red Cross and Doctors Without Borders. What insights would you hand to them for a similar situation? We hope we don't have a similar situation, but still.
Yeah. I think one of the things that was really frustrating, from the beginning, and maybe still to this day, is just a lack of overall coordination from a federal or even global scale, right? There's so much opportunity. We have the technology to do that. So, there's this opportunity perhaps to have a standardized design that we can all be, certified and shared and can be distributed for everyone to make. There is so much potential in this idea of using local making, small scale making to sort of crowdsource, solutions in times of need. And I think the face shields are a perfect example of that, where we went from, 3 or 4, labs, people just sort of printing overnight, but then it's quickly spread through the entire community and people dropping off, the solution. I think that's really the big opportunity. And I think as the technology evolves and we solve porosity problems and other material, challenges in 3D printing, that maybe at the desktop scale, we could provide something that could, really provide protection. But this idea of physical goods, crowdsourcing of physical goods, crowdsourcing of making is really, that's still a huge potential. It's something we'd always talked about, but never really had a chance to execute. And so that was really a trial by fire kind of experience. And I think it showed there's a lot of potential there.
I agree. So can you, this is a question from an ICAT old timer. It's good to see you, Adam. Tell us about a special moment from this experience, a joy or a challenge, and something new that you learned from that agile iteration.
Joseph, you have anything you want to add? You want to start with?
For me, the joy moment was the vacuum forming. Watching that go from Genevieve and a lot of the students who were working on that project had never used vacuum forming before, and they went from never having used it to the kind of fully realized version of those vacuum formed masks in a matter of a few weeks, and seeing that first successful vacuum forming of those masks was just really special. It was really exciting to watch that cycle happen.
I think for me, the things that I took away from this is, I'm a big believer in collaboration and coordination and improving our, leveraging all the expertise we have on campus to do something bigger than what we can do alone. And I've always believed in it, and I've seen it before, but I've never seen it to the extent like this before. And it's amazing, you sort of reflect on what are the barriers to collaboration? Why did this work so well? Like there was no discussions about resources. We were literally everyone was going to their supply closet. No one was worrying about being reimbursed. Carillion at one point asked us, how much is this going to cost? And we thought, oh, we haven't even thought of that yet. Eventually we should acknowledge, that Michael Friedlander and the folks there at Carillion Research Institute did provide funds to support the cost of supplies. But at the beginning, no faculty was worried about resources. No faculty was worried about whose name goes first on a paper or invention disclosure. When we put those things aside, and also there was no ego. I took lessons from about Blacksburg High School students on their, use of 3D printing. We went back and forth, right? Everyone was coming in just with a sole concentrated focus on coming up with a solution to help those in need. And when you do that, it's amazing what you can accomplish. From an educational standpoint, the thing I really see is every class I teach, I always put in a final design project, a truly open-ended project where you have to apply what you've learned to create something new. But still, it's only times like this when you really have a customer in hand that you go back and forth with, do you really get a completely different level of commitment and energy from the students. There's so much response to that. And I've always known that Virginia Tech students are outstanding, but they continue to surprise me and exceed my expectations. And this is really no different there. It was outstanding to see them, they didn't watch. They were not staying at home watching Tiger King. They were, working all night on this problem, and probably watched a little Tiger King too.
Of course. Bob Leonard has a question that is really similar to one that I have. This transdisciplinarity and this collaboration across so many different disciplines and ages and generations is just beautiful to see. What problems with collaboration did you solve that others could learn from? And I want to say first, Chris, you've been part of ICAT for a long, long time, and Joseph, you too. So I think this habit of working across disciplines is one that you've probably developed over the years. And I'm just going to put a plug in right there for that practicing of that effort. And I'm sure that helped. But I'll ask that question. What did you run into problems with collaboration, with vocabulary? And what could you give to another collaborative effort to help them move forward?
I don't want to sound Pollyanna here, but we didn't really run into a lot of issues here. It's because the needs and the time was so tight, the needs were so clear, and everyone's motivation was shared. And it sort of goes back to those earlier comments about the common barriers to collaboration that were completely absent here. And and then helps us think about, well, how can we going forward continue to sort of assuage those kinds of concerns so that we can just get to the task at hand. It was everyone's shared priority and interest. So there wasn't a lot of that. The only real conflict that we had was actually that story I told, which was a classic like engineer and customer, where the customer comes in and says, I need this, and the engineer says, no, you don't. I know what you need, and I've already come up with a solution. And so there was a one afternoon where I thought, I can't believe I'm living in a Dilbert cartoon. But we finally, the next morning though, everyone had sort of slept on it, and the design and sort of the collaborative design between the actual user and the designer came into play. And that Slack, I was so happy to have Slack as a way to document that sort of design story, and to see it happen literally in 5 hours, to go from, I mean, literally that was the only meeting that got a little awkward, to then complete solution and implementation within a day. It was, I wish I could replicate that. I wish I could put that in a class and have students relive that, because it was the most eye-opening and a valuable learning experience for everyone involved.
Wonderful. Well, there are a couple other questions. We're going to have to pass on those this morning. We are out of time, but we want to thank you so much for being here, and thank you for your wonderful contributions throughout the summer, and also today for sharing it with us. Next week, we'll be doing Benthos 360. It's a wonderful underwater immersive experience. So we'll be talking about that. So we'll see everyone same time, same place next week. Thank you again, Chris and Joseph.
Thank you.